This talk is on Extensible DevSecOps pipelines with Jenkins Docker Terraform and a kitchen sink full of scanners by Richard McGuire. I'll let him do the self-introduction, but he's from Modus Create. Richard?
Sure. Hi, I'm Richard Bullington McGuire. My wife and I hyphenated, so I'm the Bullington part and she's the McGuire part. And I'm a principal architect at Modus Create. We're a software product consultancy out of Reston, Virginia, and we're one of the sponsors of the conference. And over the last several years, I've been working with DevSecOps concepts and practices quite a bit, and I wanted to show you some of the work in progress and share the repository that contains all of the consolidated demos. So go ahead and see if it will present for me. Yes. Okay. So how does all this stuff fit together? Okay. You might have all these tools. You might wonder, does this even make sense? That you need to pick something that is going to run your pipelines, provide an auditable path that other people can see. Now, there's so many different ways you can mutate infrastructure out there. And if you don't have a good trail of what happened, you're going to be in big trouble when the next person comes along and tries to mess with things. So I'm going to show a little bit of the setup that powers this. Okay, so we have a Jenkins server that talks to our GitHub account, and we have a repository in it that has a Jenkins file. So are folks here generally familiar with Jenkins as a CI system? Yeah, okay. It is not the sexiest CI system. It's getting a little older, a little creaky, but it's in place in a lot of different places, and it's very flexible. Despite its shortcomings, it gets really heavy use in a lot of the accounts that I work with. So one of the things that I've learned over the last decade is that you can use Jenkins to act as like a task runner, and if you use it to act as a task runner, and you set things up right, you can have it run anything. And this includes running your infrastructure as code tools. So the pattern that this repository uses is to be able to run a whole host of infrastructure as code tools to deploy and maintain the little baby applications that live in this repository. I can run Packer to build a new AMI using Ansible scripts to build up the right set of packages to support the applications I want. I can create code deploy archives. AWS Code Deploy is one of these tools that lets you deploy applications that maybe have a complicated install process. Maybe they're legacy applications. Maybe they've lived in the data center or under someone's desk for the last 10 years. And now, lucky you have to get this stuff to the cloud. And there is no way you're going to spend less than, say, a year 12-factorizing this thing and splitting it into a fleet of containerized microservices. What do? What's a practical approach? This provides kind of a middle way. So, I could check some of the boxes here to tell it to package a new code deploy archive from my latest code base. I could say deploy the current one. Apply Terraform if there are any changes to infrastructure. I could even tell it, like if I've had Terraform rotate in a new AMI, to actually rotate all the servers out so that those use the new AMI instead of the old one. I can also run load tests from this. So I'll run a little baby load test on this, just like a 2-minute one as part of this. This load test won't run unless the software deploys correctly. And that's been an issue, for me since about 2 o'clock this morning. So one of the nice things about code deploy is that it will roll back to the last known good deployment. So you'll see in the code deploy console with all the deployments that there's a huge march of failed, succeeded, where the new things I've been trying get rolled back, and then the older version that was good gets put back in place. This is one of the other nice things about code deploy, is it lets you do this. Okay, so I've got this in here, and I'm going to let it rip. Except, of course, if I'm doing things that like would let me destroy my entire set of infrastructure, I don't want to do that by accident. So I've got a little CAPTCHA system in here that relies on modular arithmetic. It's not RSA, but it's very effective at, like, I don't just press the button by accident. So 8 plus 10 minus 5, I think that's 13, right? Okay. If I get it wrong, it's going to fail fast and nothing's going to happen. Which has happened in multiple of the demos that I've done, with this stack. Okay, so this is now happily running a bunch of software. A lot of it is running as Docker containers. So this setup doesn't use Docker to deploy the applications, but it relies on Docker very heavily in order to spin up Terraform itself, to spin up Ansible, or to spin up Packer rather, which will then run Ansible on an EC2 host in order to provision it. And I'm just going to go ahead and let this run right now. It's doing some validations on the scripts, and it'll take a little while, and we'll come back to this. So why bother with DevSecOps at all? What you want to avoid is the swirling snowflake hell of all the servers that are maintained by hand, that are patched by hand, that nobody really knows how to how to make them secure. Okay, at best you'll be able to get a golden image and keep punching away at that, and maybe you'll take your golden image and deploy that in your fleet. But you won't know how to get it up there. Or if you're really unlucky, and I know that some of you, given the sponsors here, must work in defense or intelligence, you'll have to deal with what used to be called information assurance, and I guess now is risk management framework. So I hear DIACAP is dead, which makes me very, very happy, because that security framework relied a lot on checking the boxes and not necessarily assessing the risk of realistic security threats. There's some benefits to doing that. You want to make sure that you have a checklist-driven system in some cases. The new way is to write infrastructure as code. Treat your servers as not as pets, but cattle. You might nurse the pet back to health, but if one cow in the herd is sick, it gets culled, and you pop a new one in its place. Or since I'm a vegan, I really prefer the houseplants versus crops analogy, but it's never going to catch on. So, The thing with DevSecOps is you use the same tools that you use to build out the infrastructure in order to ensure that you have a secure environment. Okay? That's really it's that simple. So, well, how do you make a system secure? There is no one answer, but a great answer that people keep coming back to is defense in depth. You want to have firewalls. You want to have intrusion detection systems, maybe. You definitely want to make sure you know what ports your system is listening on. So the code here has two different checks on this. It does a check when you first build your baseline image. And in the architecture here, you build kind of a baseline image that maybe would be useful for deploying one or more applications. It's not the tightest, most focused way of doing this, but it's very practical if you have an enterprise that needs to trust that golden image and make sure that it's gone through the security checkpoints it has to have before it makes it to production. And then maybe you put a PHP application on it, or a Go application, or a Node.js application on it, or a Java application, whatever. It doesn't really matter what goes on it after that, but this lets you focus your efforts on that one image. Okay. Otherwise, you have to do n images for n runtimes, and that can be really painful. I've presented on variants of topics from this repository before. And the innovation here in this one is this also attempts to check things when it deploys. Okay, we'll find out if it actually worked when we come back. And if it didn't, we can dig into a little bit and find out why it didn't work. Okay, this is an incremental iterative process. So, and with the safeguards that are in place, you can continue to hack at it until you get things to work all the way through. And then you can try to climb up the next ladder. So what's not in here is checking on schedule or checking on demand. There are other products that deal with that, but it's just not in scope for this. So about me. I've been doing stuff on the internet for a long time. I've had my nonprofit, the Obscure organization, on the internet continuously since March 1995. I had a 28.8 full-time Slip account when I started out, and now it's Verizon Fios with tens of megabits a second bandwidth. And I've personally sort of shuttled between technology and business. I've run small consulting companies. I'm a versatilist. I know a little about a lot of things, but when it's necessary, I can dive all the way down to the bottom of the stack to solve a really thorny problem. And in the last decade, a lot of these thorny problems have been in cloud deployments, in scaling, performance improvement. So, in the last 5 years, I've done a lot of work with AWS and infrastructure as code. I did a lot of work about performance improvement, where I got to improve the performance of these systems. And performance and security are very closely related. Now, you use the same kind of toolkit in some cases to hit performance as you do security. You measure. If it's not quantifiable, then your grasp on it may be weaker than you think. And you also have to worry about validity. You can do as many load tests as you want that test your site under a 10-user load, but if 1,000 people come and hit your site on the busiest day of the year, you're going to be in big trouble. In 2017, the scale of the challenges that I got to tackle got much larger, and I helped a large education company migrate their 14 mission-critical applications from a data center environment where things were managed with Puppet over to AWS, and it used a stack that was similar to the one you see here. More sophisticated in many ways, but it's very similar in concept. It has Jenkins, it has code deploy, it has Terraform, it has task runners, So this kind of thing is a very reasonable way to migrate some legacy applications. Now, with that endeavor, mandate was don't make security worse. Okay, we already have enough problems. Don't make it worse for us. So we're like, okay, we'll take this DevSecOps approach. We'll make sure that we have CIS baseline remediations to our golden image. We'll work with the security team to get that scanned. I have another talk that's also linked to in this that goes into that in a lot more detail if you're interested in that. And there's a brand new thing I learned just this morning that is kind of an impediment to doing the same kind of work that I did over a year ago, which is unfortunate. I'll get to that. And in the year since, I've done more work along these lines and built out this demo, which is MIT licensed. You can use it and adapt it for whatever purpose as long as you give credit, and retain the copyright notice. So the education client that I dealt with, I learned that they actually called the combination of Terraform and code deploy Richard's stack, which really bugged me. So I tried to find a better name for it, and the only anagram of Terraform and code deploy in the English language is corporately deformed. Okay, this stack is an ugly baby. It's got a horn sticking out of one eye, but it has muscles where it counts. And if you need to scale to massive size, and have tens of thousands of simultaneous users, you can use stuff that's in this toolkit to get there. So, this large education company ended up with, over 100 running EC2 machines at the peak, and you can see just a little bit here, the Terraform. So Terraform has, whenever you make a change to your Terraform stuff, presents you with a plan to execute those changes. And in this case, we were making huge numbers of changes, quite a bit. It's like, oh, we're ready with the first 6 applications. Okay, we have to get the next 3 out in 2 weeks. What do we do? They have new databases. They have new requirements for caches, all kinds of weird, wacky stuff. So we would do things, and we would end up with dozens or hundreds of changes with Terraform. And we were able to do this with successive environments. Having a dev environment, having a staging environment, having a production environment. And if you make sure that you use kind of the same kind of discipline you'd use when deploying an application to these, then you can have the same discipline about your infrastructure as code and the same discipline about your security controls. So this was really large, at least this is probably the largest system that I've worked on in my career so far. And some of you are like, that's not large. I deal with exabytes of data all the time. But for me, this was a big deal. And the peak load on this, like before this, the system that I dealt with that had the highest peak load had to have 2,000 simultaneous users. And I spent 2 years getting it to that point very painfully, like inch by inch. And with this one, it's like, they already had tens of thousands of simultaneous users at peak, and it had to perform when it was migrated off of their old infrastructure into the new one at the same level or better. Because, the whole company's future's on the line, given past mistakes. And this helped get it done. New Relic to monitor the whole thing, which was very important to be able to get it right. There's probably other tools that could do it as well, but this is the one that I've seen bring the best results when you have something of this scale that's on the line. You're like, well, what about Docker? What about Kubernetes? What about Docker Swarm? What about all those other things? That's great, but you might not have a year to rewrite your applications and 12-factor auth them, okay? The benefits that stuff brings are huge, but you're going to have a huge refactoring in order to do it. It might cost, if you have a dozen applications, it might cost you $3 or $30 million to redo all of that stuff in a containerized microservices 12-factor auth world. And then you'll have a 30% decrease in your operational costs. Well, that's nothing compared with the development time sometimes. So, and it's really hard to stuff legacy apps into containers. If you need a writable store somewhere, or you need something really weird in the setup, it's just not going to happen. You're going to have to find another way. This way works pretty well. This repo supports local development. It has Vagrant and a Ansible setup that allow you to kind of massage your golden image using Ansible scripts, before running it on AWS through Packer. And then, once you've debugged your scripts a bit, you can use your local dev to initiate a Packer run, run Packer through Docker, and have it create a template image on EC2, a fresh AMI from a vendor image, and then apply all the changes on it. So this particular stack is like a fairly simple Nginx Python stack with a little sidecar of Ruby to help with some of the automated testing stuff. So I showed you a little bit about this, but really it's not good enough to just do this on your local system. If it's just you, then maybe you can get away with it. But if you're working with a team of size 2 or more, you really want everyone to be able to see every run of that Terraform does, especially in your prod environment, especially when you apply the changes. Okay. The way that that this works for getting the applications to scale involves AWS Elastic Load Balancing and auto-scaling group. So the modern apps should probably use the application load balancing, and I think I had some of that in my notes in the abstract. But this one uses the old school Elastic Load Balancer, which has a few advantages and a lot of disadvantages compared with the ALB. But it works. And all of the code deploy bits, like they get assembled in Jenkins. There's just a script that creates a zip file, and it has a manifest, and the manifest says where the code goes, and it shows it shows, it has scripts that have hooks, like, oh, before the application starts, run this script. After the application has started, run this validation script. And with that kind of structured approach to deploying applications, you can take very different applications and write scripts that will work for all of them, under Linux or under Windows. And I've used it in both environments. It's easier under Linux by a factor of about 4. You really want to use Packer, or some equivalent tool to create those machine images. Now, this is the bakery pattern. Now, there's some companies like Netflix that take the bakery pattern to a further extreme. So they might bake their entire application and all of its code for every release into a separate machine AMI. Okay, at least they used to. I read some articles about this, and that's a nice way to do it. But it's also inconvenient because you're going to have dozens or hundreds of AMIs floating around, and you're going to have to deal with the life cycle of those. They all take up storage. You're going to have to audit which ones are running in production. If you had one golden AMI, it's really easy to see, like, oh, I have 40 instances running in EC2, and 38 of them are the new one. Why are those old ones hanging around? I don't care. I'm just going to kill them off and let them get replaced by the new ones. During the bakery process, run security scans. This is where the DevSecOps comes in, or at least part of it. So this repository has 2 types of scans built into it, OpenSCAP and Gauntlet. So OpenSCAP is one of these security tools that's come out of the kind of Red Hat world and the world of kind of big checklist-driven security. So this will spit out a beautiful checklist report for you if you use it correctly. And Gauntlet is like a Swiss Army knife. Has anyone used Cucumber, maybe with Selenium to do automated testing, for web applications? No, it's one of these domain-specific languages that makes it easy to understand kind of what the steps in a test are. So I'm getting a lot of blank stares on that one. The nice thing here is you write some simple features with scenarios given and when this is the result, and when you're done, the test runner goes and runs steps that correspond to each of those things, and the test is green when it's done, and you know that it's worked well. Okay. So I have a couple Cucumber reports here for the interim failures that I encountered this morning while trying to publish my talk. Okay. So these are from Gauntlet. So, I started out over here. I'm like, what is going on with my stupid testing tools? This was working great before, and now it doesn't work at all. Oh, wait, I didn't try to run it like this. I'm trying to run it a new way, so I have to make sure the environment's good. In this case, it couldn't write to some temp directories. So I did a bunch of chown and chmod stuff on that, and got it to the point where, the only thing left was, like, it can't find an XML file. Okay? So the last commit I did is intending to fix this up, so hopefully this one will run clean. We'll find out soon enough. But you can see that there's plain English in these scenarios. Okay? Like, when I do this, the output should match blah. And all the Gauntlet stuff is built like this. So, there are people who built, like, attack components for many different tools. I just have Nmap and a file verification tool here, but there's all kinds of great stuff that you can dig into for that. The OpenSCAP stuff has another set of reports. So I have a good Packer build here, which will show one of the OpenSCAP bits. Like, is this going to show up as raw HTML, or is it going to show up nicely if I click on it? I guess we'll find out. Oh, it showed up nicely. Okay. So, secure configuration of Red Hat, Linux 7. This is a report that a manager or a security officer would probably love, especially if it had more than 9 items on it. Okay. One of the real bummers that I found is that the definitions for the security scan I had been using are no longer shipped with CentOS. And this is like a much, much weaker set of stuff. And if you want the full-blown security test definitions, you really need to be a Center for Internet Security member. And that is kind of expensive on an individual project basis. They'll give you a license to do it on one project for about $1,000. But if you're an organization, it's like membership on a sliding scale. So if you're a giant defense contractor, you're going to pay them, I don't know how much, hundreds of thousands of dollars a year. And if you're, a mid-sized contracting company, you're going to have to fight for that budget because it's going to be pretty dear. When you use these scans, you want to make sure you understand kind of where your scan results are before you deploy. Know what risks that you're taking that your scanning tools come up with. It's just, you don't want to go in blind with it. So Gauntlet, I showed a little bit of that. Now it's a Ruby framework tool, so you have to have Ruby in your test environment somewhere. I chose to put it on the host that's being tested, which is convenient, but has drawbacks too. Maybe you don't want to do that. But the extensibility of that is really wonderful. The big bummer again is the C2S profile doesn't ship with CentOS. C2S was derived from an earlier Center for Internet Security baseline. It was a U.S. government security profile, but it's no longer there. I'm like, where'd my profile go? I had 60 different controls that were imposed with this, and now all I got are these 7 lousy controls. So that was disappointing. You can see more, and all this stuff is linked into the main talk too. So you can see all the links for the different talks and their slide shares, in the link to the repo. Okay, bakery scans, Gauntlet, and OpenSCAP. So I showed a little bit of this about kind of how they were showing up, but I'm going to also show kind of how they're hooked in and where. So you can see here that this Jenkins output is from a Packer run that worked. Okay, I'm like, yay! This is in UTC, as all good server times should be, and it's embarrassingly recent, but it is what it is. So when you run Packer, I'll make this a little bigger so you can sort of see it. Okay. I have a bunch of scripts in here that do more than just run Packer. I lint all the things. I lint the shell scripts with shell check. Okay. So if you so much as have some missing quotes in your shell scripts, this thing is going to be like, I'm not going to run any of your garbage until you fix the problems in your scripts. And you should hook in every linter you can for every language that is used actively in your project here, so that you cannot have the development team screw it up by being super careless. So they can still screw it up, but they have to work it harder. So Packer, when it runs, spits out a whole bunch of output. Hey, I'm spinning up an Amazon box. Hey, I'm setting up all the key rings. Hey, I'm going to transfer this stuff over. And then it runs whatever script you give it. So in this system, this comes in through Packer. Packer has a JSON file. It defines some variable wiring, and then it just runs some shell scripts on your target machine that you're building, the image. So there's some scripts here that will install the tools and then run Ansible to do the tests. Now, Packer has support for Ansible, as one of its provisioners, but if you're going to lock your system down, it's not going to work. If you have a non-writable temp directory, that provisioner is not going to work. Okay, so this has a lot of stuff to work around that, because when you have to lock it down tight, you also want your scripts to work in an idempotent way. You're like, I locked it down once. Can I rerun the lockdown suite on it? If the answer is no, you're going to have to rebuild it every time whenever you make a change, even locally. Okay, you won't be able to do the nice thing where you have, a terminal window that's open in your nice little, local Vagrant environment here where you can run the same scripts. It's really nice to be able to do that. It's really nice to be able to do, a Vagrant provision and have it kick off the same Ansible script that you'd have running through Packer. Okay. And in this, at the very end here, like it does a whole bunch of stuff. At the very, very end, it ends up scanning the server with Gauntlet. Okay, like this makes very heavy use of Ansible as a task runner, but you could use whatever you wanted. You could use shell script, you could use Chef, you could use Puppet, whatever corporate standard you've got for that stuff. You could build something like this. And then at the end, it copies the files out of the host that it's just templated and back over into the workspace that's been checked out to run things, so that maybe your CI system could archive it. So, the CI system archiving it is also great to have, and it's one of the huge benefits of running this stuff in CI. Because if you didn't have the CI system archiving it, you'd probably just throw these away every time. If you do this, you can come and see. Oh, well, this has worked. Did this one use that lovely system for doing the scans? I could come back to one of my older ones, and if I found one of these, like this is probably it. Yeah, the baseline. So, for my previous thing, the C2S profile. This has, look at this. This is great, right? It's like, wow. There's a lot of things in here, but this doesn't ship with it anymore. So you're kind of stuck not having that now, which sucks. I don't know how to get it, but if I've spent 3 hours of internet research, I would probably find out. Okay, moving on. Any questions so far? The audience has been very, quiet. Is it just that you're tired after lunch? Or am I really boring? I don't know. A lot of information. There is a lot of information here. This is essentially like the quick version of the last 4 years of heavy duty work that I've done for multiple clients. Hardening. Okay. If you are going to harden your image, you have to decide, are you going to do that hardening before or after you install your software? Maybe you have to loosen things up a little bit to install your software. Maybe you'd have to do that at deployment time. If you're running SE Linux, if you're running a legacy app, you might have to disable SE Linux temporarily to get the darn thing installed. Hopefully you can turn it back on afterwards. But if you're using this CIS hardening baseline, there's a bunch of Ansible scripts in here that right now are turned off because it interferes with code deploy's correct operation. I have a bug in my repo to fix that. And I wasn't able to get to it before this talk. But we have had that working before. Where code deploy and the CIS baseline remediated images play nicely together. But it was tricky. It was very tricky because of things like, there's no more writable, or you can't have an executable file in your temp directory, or there are no SUID files allowed on that in the home directories. So, you run into some rocks and you need to do a lot of work to do it. And here's the big question. Do you want to fix all the upstream bugs in your vendor's software that prevent them from installing correctly? Probably not. Is that a good waste? Is that a good use of your time? Probably not. And if you're going to run some of these scanners, you also have to decide, am I going to fail fast on every violation, or is there a certain level of violations that's acceptable? Okay, a lot of Jenkins plugins classically, like the violations plugin, have a threshold. They say, if you have 90% success on these tests, it's good enough to pass. If it gets worse, then you're going to fail. So you might want to consider doing something along those lines in order to start in a good place and then be able to push things out farther. Terraform. Terraform is super awesome. How many people have worked with Terraform? How many people have worked with, say, CloudFormation and the equivalent on, say, Azure or, Alibaba or something else. Okay, like all of these systems let you provision cloud infrastructure, database servers, load balancers, all of that stuff by writing code, and it is the way to do it in 2019. You do not want to be spinning up stuff in the console except as proof of concept test while you're on your way to writing this stuff. Terraform is also great because it has plugins for every major cloud provider out there. It'll do Amazon. It'll do Azure. It'll do Google Cloud, and many more. You can use it to provision your VMware machines if you want. And if you're not using anything to provision your VMware machines, you should strongly consider using something like this to do it. You can use Packer to spin up VMware machines. You have to run VMware machines locked in a
Hi folks, Alan Geek here. Unfortunately, we had another video/audio freeze. Track 2 seems to be our problem child at this con. I let the person attending the video station know to stop and restart OBS if this happens, and we'll just do a part 1 and part 2 and combine them. Sorry for the inconvenience.